I hope all of you are doing good. Let's start today's chapter, set theory. In class 6, we have learned that a set is a collection of well-defined objects, things, people, symbols, etc. And we had also discussed in detail the following concepts related to sets. Number 1, definition of a set. 2, description of a set by description method, roster method, and set builder form. 3, different types of sets, finite sets, infinite sets, equal sets, equivalent sets, and null set. 4, cardinal number of a finite set. 5, union and intersection of sets. 6, overlapping and disjoint sets. 7, Venn diagrams and their usage in representing sets. In this chapter, we shall consider the following concepts related to sets. Okay, use of the symbol. Okay, this universal set, equivalent sets, subsets, complement of a set, and solution of a problem using Venn diagrams. Okay, use of this symbol. Okay, we know that a set is a collection of well-defined objects, and objects in a set are called its elements. Consider a set A, B, and C, D. These are the elements of set A. Okay, so the elements of this set are A, B, C, and D, and about these elements we can say that. Okay, so we will use this symbol. Okay, A, B. Okay, now what is the meaning of this symbol? What do we call this symbol? Actually, the symbol means belongs to. Okay, or is an element of, or is a member of. Okay, now let us consider some other elements which are not in the set A. For example, we can write E and then we will use this symbol and then write. That means does not belong to. Okay, this symbol means does not belongs to. E doesn't belongs to A. Okay, or E is not an element of A, or E is not a member of A. Right. So, for example, for set A, 1, 2, 3, 4, 5. These are the elements of set A, and now we will write 2 belongs to A, 3 belongs to set A, but 6 does not belong to set A, right? Next is universal set. Any set which contains all the elements of various sets under consideration is called a universal set. For example, consider the sets. A is equals to 1, 2, 3. These are the elements of set A. 4, 5, 6 are the elements of set B, and 3, 4, 5 are the elements of set C. Now, form a set that contains all the elements of A, B, and C. So, clearly the set obtained is 1, 2, 3, 4, 5, 6. This set formed is called the universal set for the sets A, B, and C. So, we represent a universal set by U. U, okay, or also we can use this symbol also, which is read as phi. Thus, U is equals to, that is universal set is equals to 1, 2, 3, 4, 5, 6. However, universal set for a given number of sets is not unique. A given number of sets can have many universal sets. For the sets referred to above, the set 1, 2, 3, 4, 5 up to 100 can be considered as a universal set since all its elements are contained in it. Similarly, the set of whole numbers, the set of integers, and the set of natural numbers also can be considered as a universal set for the sets A, B, and C. Next, equivalent sets. Two finite sets are called equivalent sets if they have the same number of elements. For example, let A is equals to A, B, and C, and B is equals to 1, 2, 3. Now, A is equals to 3 and B is equals to 3. Hence, A and B are equivalent sets. Okay. Second, let C is equals to days of the month in April and D is equals to natural number less than 30. Okay. So, days of the month in April 30 and natural numbers less than 30, 29. So, are they equivalent? No. Those C and D are not equivalent sets. Next, subsets. If we have two sets A and B, then A is said to be a subset of B. If every member of A is also a member of B, we write it as A and then we use this symbol. Okay. So, it is read as A is a subset of B or A is contained in B, right? A is subset of B or A is contained in B. Thus, A is a subset of B when X belongs to A implies X belongs to B. If A is a subset of B, we can also say that B contains A or B is a superset of A. So, symbolically we write it as B, okay, and it is read as B is a superset of A or B contains A. Okay, for example, let A is equals to 1, 2, 3 and B is equals to 1, 2, 3, 4 and 5. Since every element of A is a member of B, that means A is a subset of B. Okay, since B has more elements than A, so B is not a subset of A, right? So we say that B is a superset of A, right? So we will write like this: B is a superset of A. Now, proper subsets. All subsets of a set except the set itself are called proper subsets. The symbol for proper subset is this. Thus, if A is a proper subset of B, we write A is a proper subset of B. For example, if A is equals to AB and B is equals to ABCD, then A is a proper subset of B and write it as like this: A is proper set of B. Thus, when a set A is a proper subset of another set B, it means that each element of set A is in B, and number 2, number of elements in set A is less than that of B. Okay, that means A is less than B. Now, complement of a set A is the set of all elements which are present in the universal set but are not present in the set A. The complement of a set A is written as A dash and it is read as A complement. Okay. For example, if the universal set U is equals to 1, 2, 3, 4, 5 and 6 and set A is equals to 1 and 2, B 2, 3 and 4, then A dash is 3, 4, 5, 6 and B dash is 1, 5, 6. Difference of two sets. So for sets A and B, their difference is written as A minus B and B minus A. A minus B means set of all elements of A which are not in B. And B minus A means set of all elements of B which are not in A. Okay. Next, usage of Venn diagrams to represent sets. John Venn, a British mathematician, initiated the use of diagrams to represent various relationships that exist among given sets. Usually a rectangle is drawn to represent the universal set, okay, U, or you can also use this symbol. Circles or oval shapes are drawn inside the rectangle to represent the given set. For example, if U is equals to 1, 2, 3, 4, 5, 6 and 7 and A is equals to 1, 2, 3 and B is equals to 2, 3, 4 and 5. Now we have to draw a suitable Venn diagram to show the relationship between the given sets. The given Venn diagram means this shows the relationship between A, B and Xi. Okay, so this is the Venn diagram. Okay. Exercise 7.1, we have to classify the following as finite, infinite and empty sets. Number 1, days of the week. Days of the week, these are finite, and set of whole numbers, these are infinite. Okay. Okay students, I hope you have understood this chapter. Now you will do practice of this chapter. Okay.